Hello people, today we'll be solving LeetCode daily question 1420 which states we have to build an array where we can find the maximum of exactly k comparison. So it is a hard level question of dynamic programming, and here we'll be given three integers n, m and k, and we have to keep in mind the following algorithm which they are provided, which is to find the maximum element in an array of positive integers. Okay, so currently they have initialized maximum value as 1 and the index of maximum value also -1, and currently the search cost is 0, and there we have initialized a for loop for I equal to 0 to less than length of the array I plus plus, and this will basically turn as the maximum index, which is the index of the maximum value which is present in the array. And okay, so what we have to do in the question, we basically have to build an array which has the following properties. Array should have exactly n integers, and also we'll be given an integer m, so every element of the array should be less than or equal to m. And after applying the mentioned algorithm, this we have the value of the search cost should be equal to k. Okay, so basically what search cost is, for example, let's take an array, let's say 1 6 4. Okay, so this is the array, and here let's say the search cost to find the current maximum would be 2. I'll explain how it would be 2, because first we'll initialize, as in the given it is given that maximum value currently is -1, as 1 is greater than -1. So firstly, in first iteration the cost would be equal to 1. Okay, so then in next iteration we'll find we'll considering 1 as the maximum value and 1 is less than 6, so now the cost will be 2. In the third iteration, 4 is not 4 is 6 is not less than 4, so the cost will remain same. And basically we have to build an array with for the given k. Okay, which states that the searching cost to find the maximum value in that array should be k. Okay, so let's delete. Okay, this was an example, and let's keep it here, sweet and short. Okay. So now let's talk about how we'll be approaching this question. So to approach this question, first we need a DP array. We'll be needing a 3D DP array for this question, as we have to find we'll not be building all the possible arrays, but we can find that how many possible arrays are possible with the given constraints. Okay, so similarly we'll be initializing n and m will be given in the question. We'll be putting them in a global scope, and the name of the function is num of arrays. Yeah, arrays, which takes parameters n, m and k. So in the main function we'll be initializing dp with n plus 1, m, oh no, n, yeah, here m plus 1 and then k plus 1. Okay, and similarly this dot n should be equal to n, and this dot m should be equal to m, and then we'll be putting some initializing all the values in the array to be -1. Let's do it by using a for loop for int I. Okay, we'll basically fill okay, I'm writing just the step, you can do it on your own. First step, fill all the values in array with -1. This you will have to do. Okay, so then we'll be having a function, let's call it solve. So what this function will take, okay, let me write the function first. So firstly it will be taking, and let's call the function solve. It will be taking an integer I, then integer maximum value we have, and int remain. Okay, so what this will basically do is int I is the index and max so far would be a value which will tell that what is the maximum value we have encountered till now in the array, and int remain is the function like how many remaining values we have to add in the array which are greater than maximum so far value. Okay, so let's consider this example again. Let's, for example, let's say in this question the at this point our remain okay, basically at this point I'm talking about when 1 and 6 our remain becomes 0, but in the question we are given n should be equal to 3 and m, let's say, is should be equal to 7. Okay, so at this point let's say the remain becomes 0. Okay, like we do, and initially okay, let's say initially in the question we were given that k should be equal to 2. Okay, let me cut this. Yeah, this is the question, and at index 2 let's say remain becomes 0. Okay, but the question states that we have to build an array of exactly n integers, so we have to choose the value for the next index, that is for I equal to 2 will be sorry, at index 1 here, oh sorry, it's from 0 based indexing. Yeah, for index 2 we should have a value which should be from 1 to maximum so far, that is 6. Okay, let's call it max so far. Okay, yeah, this is the maximum so far value we can put at index 2, but here our remain becomes 0, so we don't have to add a new value which is greater than this 6. Okay, so now for index 2 we will be having options as 1 from 1 to 6, we can do anything. But let's say in the question okay, wait, let me put this for a second. Yeah, okay, so let's say in the question it was given that k is equal to 3, and by now our remaining, we have done this, and by now our remaining should have be, we'll be having remaining should be equal to 1. Okay, so now we'll have to add a value which is greater than maximum so far, so that the remaining becomes 0. Okay, this is so, and we are having, let's say the m is equal to 7, so we can add any element which is less than in the range 1 to 7, and 7 is included. So what will be the array? It would be 1, 6 and 7. Yeah, so this is the question. So okay, let me minimize this. Yeah, so let's get back here. Okay, and then we'll have the base case. Let's say if I is equal to n, which is basically the length of array, and then we'll check if remaining is equal to 0, then we'll just return 1, that this array is possible. Return 1 here means that this array is possible, otherwise we'll just be returning 0 and here close. And also let's say if remain is less than 0, it means that we have added more number of maximums which were needed. Like for example, similarly in this case only, yeah, in this case only, if we have added by mistake here 7, this would return us 0. Okay, because that would not be possible, because in the question k is equal to 2 was given. Okay, if remain is less than 0, we'll simply return 0, and we'll be checking for in if dp of I, then max so far and remain. If it is not equal to -1, we'll just return this dp value. Okay. Just returning this. Yeah. Okay. So now let's come to the main approach. Let's initialize a variable. Let's say temp equal to 0, and then for a for loop. Okay. So now we can go from the range of 1 to maximum so far. So let's initialize I equal to 1, and I should be less than equal to maximum so far. Okay, and then I plus plus. So we'll update the answer variable with answer should be equal to ans plus dp of sorry, solve. Yeah, and we'll be calling the solve function solve for I plus 1, that is for the next index, and we'll be having the same maximum value max so far, and then remaining, because in this point remaining will not also change because we are not adding a new maximum value in the present array. Okay, so and we'll, because the it is given in the question that the answers number of building the ways of array might be very large, so we'll just do the modular of this with mod. Oh, okay, let's declare a mod in the global variable only. Let's say mod should be equal to 1e9 plus 7, or you can do 1 mod. Yeah, you can also use this or this, both will give the same result. Okay, so this was the case. Okay, but for, let's say I is equal to maximum so far. Okay, so let's say we have achieved the maximum, we'll be starting with maximum so far, and we're having the option to go to m element, like okay, let's see this example once again. In this it is given yeah, this 1671. Okay, so in this case this will not be this for loop will not execute. Okay, so in this case this will be executed, because we have to add one more element which is greater than the maximum. It's not like this will not be executed, but this will return a 0 again and again. So when the recursion call will come back, it will enter into this for loop, and for this the current maximum would be 6. Okay, and then we are having values which can be up to 7. Okay, so because in the question it was given, oh okay, I haven't mentioned it here. K should be equal to 3. Yeah, oh please don't comment that I haven't done. Yeah, K should be equal to 3. By mistake I guess I have forgotten, but yeah, when I was updating the test case, when I explained again like the remaining part, what is the use of remain, here that I have taken K is equal to 3, but due to some error I guess I forgot to type press 3. Okay, so let's get back to the question. Yeah, in this case remaining will be 1 and maximum so far will be 6. Okay, so we'll have for the next index we have the options to go up to 7. So that's why we have taken m equal to 7. Here in the question it was given already that m can be equal to 7. Okay, so let's minimize this. Okay, so wait a second. Yeah, so let's keep it here. Yeah, and then we'll be doing I plus plus. Okay, now in this case we'll be updating the answer variable with dp of so we'll call the recursive again. Sorry, I by mistake I'm calling it dp again and again. Yeah, solve for I plus 1 with max so far as I, and oh, oh okay, so here basically it should be max so far plus 1, because it's no of no use if we do the same thing max so far, because that in this case it will again consider 6. We can beat the first element and not 7. So to avoid excessive calculations, we'll be using 7, the next from the current maximum. Okay, I plus 1, and then we'll do remain minus 1, because we'll be having all the solutions. Okay, and then when the recursion will be called, it will check that I is equal to n, and then remain is equal to 0, and it will simply return us 1. So the answer variable will be updated with 1, and as answer could be very large, so we'll just simply do a mod of this. Okay, and at the end we'll be returning dp of I, and then max so far, and then remain, that should be equal to answer. Okay, so let's move to the coding window. Yeah, so first let's declare a dp array. Yeah, okay, and then int n, int m. Yeah, and here let's initialize the dp array. Dp should be equal to int n, sorry, new int n m plus 1 and then k plus 1. Okay, so then we'll have to fill the array. Yeah, it's mentioned. Okay, first, okay, let's do this. Dot n should be equal to n, and this dot m should be equal to m. Okay, and then what we'll do, we'll just simply fill the dp array. I equal to 0, I should be less than n, and then I plus plus. Then for n j equal to 0, j less than equal to m. Yeah, j less than equal to m, j plus plus. What we'll be doing, we'll be doing arrays dot fill dp of ij with -1. Okay, so and at the end we'll be calling the solve function, return solve with current index is 0, and as the array is empty, so maximum so far would be -1, would be 0, sorry, would be 0, and we'll be having currently remaining k. So let's write the solve function. Its type would be private and will be returning an integer type of value, solve with int I, comma int max so far, and then int remaining. Okay, let's call it remain only. Yeah, so first we'll write the base case, that if I is equal to n, and then we'll check if remain is equal to 0, we'll just simply return 1, otherwise we'll be returning 0. Okay, so and then if remain becomes less than 0, then we'll be again be returning 0. Then for check if dp of I max so far, and then remain is not equal to -1, we will be simply returning dp of I max so far, remain. Yeah, and now let's start with the variable. Let's say, let's call it answer, not temp. Okay, or okay, result. Yeah, result, because at last it will be yielding its result. Okay, so and then we'll be initializing with I equal to 1 up to I less than or equal to max so far. Okay, so these are the options we'll be having for next index. Then I plus plus, and then ans equal to ans plus. We'll be calling the solve function with I plus 1, and maximum so far will be same and remaining would also be same. So okay, we'll have to apply a mod for this. Yeah, okay, we should first declare the mod also. Let's call it int mod should be equal to 1 e9 plus 7. And okay, let's typecast also it to int. Yeah, okay, and then we'll simply be doing mod with mod. Okay, so now for the other test case, the I should be equal to max so far, and I can go up to m. Oh, max so far plus 1 again. I made a mistake. Max so far to I less than equal to 1 to I plus plus, and then oh okay, it's basically result. Here also let's do it result. Yeah. Okay. Result. Yeah. Result should be equal to result. Okay, let's put this is already. Let's solve for I plus 1. Oh, okay. Oh, we have already used the variable I, so let's call it num. Okay. Okay. Let's call it J. Let's call it J. Okay. Let's call it J. Yeah. And here also, I guess in the pseudocode I have used I again. Okay. Let's make J first. J. 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 Oh, I could have also changed the parameter variable in the function only, but okay, yeah, let's keep it short and sweet. J. Here also let's make it J. Okay, so yeah, solve for J plus 1, and then our maximum will be I, and oh, maximum will be J. Yeah, maximum will be, oh okay, so here I'll be have to do index plus 1. Here should be J, and here I'll be having remaining minus 1, and then just simply mod of it, and at the end we'll be returning dp of I max so far k remain is equal to result. This should work. Let's check. Okay, it gives us an error. What error is that? New int and not statement. What's this error? It's saying n plus 1 k plus 1. Okay, what's this error? Not a new. Oh, okay. I guess I shouldn't have to use it. Okay, let's run it. Okay, now what's it saying? It can't find the symbol JSON max so far. Oh, okay. rs.fill. That was just typing safe. And then oh max. So F should be capital. And okay, in one place when F should have been capital. Okay, here max so far. Yeah. Now this should work. Array index out of bound. Okay, yes, an exception. What could be the possible reasons? Okay, I'll check. Remove equal 0. I is equal to n. Okay, let me go through this one again once again. I less than n. We'll just do as dot fill dp of this is fine. Then enter main is equal to 0, we'll do return 1, otherwise return 0. And if remain is less than 0, we'll do this. If memo of dp of I, then max of our remain is not equal to -1, we'll just return that. And then for this, it should be the result. J should be equal to 1, j less than equal to max of r, and then j plus plus. And for answer, oh, okay, we're here was there. It should be I plus 1, not j plus 1. Oh yeah, this works fine. Yeah, this works fine. Okay. So, but what we can do here is we can also do a space optimization. Yeah, we'll not be needing a 3D array for this. We can do the similar work with 2D array also. So let me get a new whiteboard. Yeah. Wait a second. Okay, I don't know why. Okay, it's loading only. I don't know what's the issue. Okay, yeah, it's loaded. It's not showing no options, but okay, check with the Wi-Fi connection. Everything is fine. Okay. Uh, okay. So let's continue on this whiteboard only. It's not working, I guess. Yeah. Okay. Oh, firstly, yeah, here it should be called with index I plus 1 and not j plus 1. Yeah, index I plus 1. Sorry. Mistake. Yeah. Okay. Now let's do it here only. Okay. So if we go with space optimization, okay, that would be basically a bottom-up DP approach. Okay, let's. This time we don't need any global variables. We just simply fill the function n, m, and k. Okay. So let's initialize DP with m plus 1 and k plus 1. Okay. And let's have another array of same dimensions as m plus 1 and k plus 1. Okay, let's call it prev, which means previous, and then we'll be having the mod equal to, let's do the typecasting. Okay, we'll just simply write it 1 e9 plus 7, or you can also use 1 then 8 times 0 then 7. That would also work fine. Okay, so let's fill the DP array, the previous array basically. It's for, we'll be using a for each loop for int I in prev. We'll be just using fill. Let's call it fill only. I with 1. Okay, this time we'll be filling with 1 and not -1. Okay, then we will be using a for loop. Okay, this is a little too big. Okay, yeah, this place is fine. Okay, a little bit, yeah. Then we'll be initializing a for loop for n minus 1 to n greater than or equal to 0. Okay, so it basically tells the number of elements we have to fill. Okay, and then we'll be initializing dp. Okay, because with m plus 1 and then okay, and then k plus 1. Then what we'll be doing I equal to 1 2. Okay, no. Okay, no. We'll be having. Okay, let's declare a variable again, max so far to. Okay, I'm writing it msf max so far should be less than equal to m. Okay. Okay. So and then less than equal to no. Okay, max so far. Oh yeah, we'll be traversing back. So max so far should be equal to m. Like that is the maximum element which we can add to m. Okay, msf should be greater than or equal to 0. And okay, and then we'll be using another for loop for calculating the remaining. Let's call it remain. To remain, okay, here we'll be declaring remain should be equal to 0. To remain less than or equal to k, yeah, and then just simply k remain plus plus. Okay, now let's have variable result. Let's initialize it to 0. Okay, and then again we'll be checking for result should be equal to result plus. In the previous TP we'll be checking max so far and then remain. Okay, and we'll be simply doing the mod of this. Okay, here it should be this. Yeah, and we'll be simply doing the mod for it. Okay, so what this will do, it will go in the previous DP and it will check for this index and it will simply add the value, like how many possible solutions were there, to this current result. How many possible solutions, like initially result is 0, and this will just simply go to that index and tell me how many results were possible using that. Okay, and then after this, if I get that if remain is great, okay, here remain is greater than 0, it means that I still have to add a new maximum element in the array which is greater than maximum so far I have added, and it should be less than m. Okay, so now let's run a for loop again. For, let's call it a temp variable. Okay, temp should be equal to max so far plus 1 and temp's range should be less than equal to m. Temp is basically the variable which we are going to add in the array so that our remain becomes remains decrements. Okay, and temp my temp plus plus temp plus plus, yeah, because we have to add more events. Okay, and then what we'll simply do, we'll do result should be equal to okay, I'm initializing parentheses early plus prev of temp and then remain minus 1. Here remain minus 1 is being done because we have to find the number of possible ways without just before that remaining. Like for example, if we are having remaining 1, what were the number of possible results which were present when the remaining was 2? Okay. uh, okay, and after the about the for loop, when we'll be in this for loop basically, uh, oh basically when we'll be in this for loop, we'll just do rev should be equal to dp. Okay, and at the end we'll be returning dp of 0 and k. This will give me the final result. Okay, here basically I guess I said that to my at the last index, but it will be checking for the next remain minus 1, that would be 0. Okay, so okay, let's reset the solution. And now let's start with the coding. Okay, let's call array dp array with new int n plus 1 and then k plus 1. Okay, another dp array, let's call it prev new int n plus 1 k plus 1. Okay, then we'll be filling dp with 1. Let's use a for each loop for int I in I array in prev. I will just using arrays dot fill I with 1. Okay, yeah, and then we'll be diving into the solution. Then for int I equal to n minus 1 to I greater than equal to 0 I minus minus. Then we'll be initializing the dp array again. dp should be equal to new int n plus m plus 1 k plus 1 m plus 1 k plus 1, and then a for loop for int max so far equal to m and max so far greater than or equal to 1. Yeah, I guess here I have written max so far should be greater than equal to 0, but I guess with 1 that should also work, because we have to enter the least positive integer, that is 1. Okay, and then simply max so far minus minus. Then another for loop for int I remain equal to 0, remain less than equal to k, remain plus plus. I need a mod also now. int mod equal to, let's typecast 1b9 plus 7. Yeah, remain plus plus, and then we'll be like int result should be equal to 0. Then okay, then for loop let's call it temp. Yeah, temp equal to 1, temp less than equal to max so far, temp plus plus. Okay, and then what we'll be doing, we'll be just updating the result should be equal to result plus result temp. I'm getting confused because of the last question. temp equal to, oh oh so, guess I made a mistake. It should be, yeah, result only. Result should, how can temp, yeah, result plus prev of max so far and remain. Okay, so after this for loop we'll check that if remain is greater than 0, what we'll do, we'll initialize a for loop again, and let's call it temp again, should be equal to max so far plus 1. Okay, and temp should be can be less than equal to m, and then temp plus plus. And what we'll be doing, oh, here I have to do the mod also. Okay, mod, yeah, result equal to result, okay, result plus prev temp of remain minus 1, and then simply mod of it, yeah. And then what we'll be doing after this loop, I'll just be doing dp of max so far, no, okay, here, not here, not in this for loop, in this for loop, yeah, dp of max so far and remain should be equal to result, and then I'll just, what I'll do, yeah, here I'll be doing prev is equal to d. At the end I'll be returning dp0 and k. I guess this should work. Okay, okay, there's a spelling mistake. Okay, so there's some error in this. Let me go through the code once again. What's the error it's saying? For n equal to 2, n equal to 3, it's not plus 0. Okay, so let's, okay, this, let's try something else. Okay, n equal to 0, but I'm changing something. What we will do, we'll just simply do dp I of 0 should equal to 1. Okay, let's try with this. Okay, still okay. Why I did this is because will not be filling all the values with 1, as it will give me wrong answer, but just the 0th index with 1, because at least 1 will be there in the array because it has to be maximum. Okay, because the array might not be possible, but at least we'll be adding 1 into that array so that it will give us at least one current maximum. Okay, it's still giving me but wrong answer. Okay, let's dive into statement once again. Initializing the dp once again. So far equal to, okay, let's go with 0. Okay, Okay, it's still giving me a wrong answer. For remain equal to 0, remain should be less than equal to result. Then in the result I'll be having a 1 and temp should be less than equal to max so far, and then temp plus plus, then since the result should be equal to result plus k result should be of max so far, and then remain, then mod. Then after this for loop we are checking that if remain is still greater than 0, we'll be moving initially max of far plus 1, and temp should be less than or equal to m, and then temp plus plus result should be equal to result plus this, and okay, then here max of far, and then okay, I don't know what's the error here. Okay, let's go with the code once again. Initialize the DP array with m plus 1 and k plus 1, then in previous DP should be equal to m plus 1 k plus 1. Mod should be, okay, I have done the mod also. Is there any place else that I have to do the mod? Okay, maybe I might be wrong. Okay, die equals 0, I less than dp dot length, and then I plus plus the dpi. Oh, here it should be prev. Okay, because yeah, okay, so that was my mistake only. Okay, so it's here, it should be prev. Yeah, this works even fine, and this was it for today. It was a long video, and thank you for sticking around. You can also follow my Instagram page, is Kabir Coding. There I am posting videos related to machine learning. Haskell we are doing over there, and there will be tidbits of DSA also. And thank you for watching.